Research Group talk. Now that we've sorted these technical issues out, we can get started. Can everyone that's online see the slides and hear us okay? Vasu, can you hear us?
Yeah, no problem.
Yes, the audio is good.
Okay, great, thanks.
Thank you.
Okay, so today we're going to talk about maritime emissions. As you know, this is a pressing issue. This is a pressing issue, and it is part of our attempt in Clean Energy Research Group to bring some of the newest ideas from our engineering colleagues, including my colleague here, Hossein Hagh Parast, towards a policy discussion. And that's what the Clean Energy Research Group is designed to do. It's designed to bridge the gap between what's happening in the technical space in terms of research and innovation and the conversations that we're having both in the public and in policy circles, so that we can not only find technical solutions, but we can find solutions that will be acceptable and approved by policymakers, as well as funded over the long run, so that we don't continually go through this churn of policy decision-making like we are around the carbon tax, where we have great technical solutions that are never fully accepted by the public, and then the next time the election comes, everything gets reversed. So as most of you know, we have a monthly meeting here, either in Harbor Center or in Burnaby, and everything is online and hybrid. We set that up a year in advance. So if you have any ideas for the next meeting, let me know in August. Line up for fall. We're happy to tackle topics that are of interest or to help you to present research that you have that's in progress. And on our website that you see here, you'll see a series of policy papers where we've written up some of the conclusions of this cutting edge research. So maritime emissions. Maritime shipping carries 80% of physical trade across the globe. And despite the fact that we're in the middle of a tariff war, the fact is in Canada and elsewhere, we rely heavily on a daily basis for shipping for most of our goods. If you think about any of our electronics, if you think about our off-season fruit, if you're buying cherry or raspberries now or grapes, they're probably coming from Chile. Electronics and probably a lot of auto parts are coming from China. So even though we have an integrated economies in North America, even within North America, most of the trade relies on shipping. Now, it only constitutes 3% of global GHG emissions. However, it is an area where there's been a lot of policy discussion. So the IMO, the International Maritime Organization, has promised to reduce emissions by 40% and try to reach net zero by 2050. That is the 2023 strategy as announced. And what we're going to talk about today are what are the challenges for reaching those internationally stated goals? What are the challenges in terms of technical feasibility? What are some of the economic constraints? And particularly at the end, to talk about some of the policy obstacles to achieving those goals. So you'll see that maritime shipping, it doesn't account for that much of GHG, but what we find is that a lot of that shipping, like a lot of aspects of climate change, are concentrated in just a few countries. So in this sense, if you could start to make inroads in some of the EU carriers, the American carriers, and China and Japan, you can make huge inroads in reducing maritime emissions. Now, you'll see some other countries up there that you wouldn't think are shipping powerhouses, like Bermuda. And this is because of the peculiarities of global maritime governance. That is, they have flag carriers. And these are used, obviously, to reduce liability and to reduce insurance costs. And so we have all kinds of countries like Liberia and Bermuda that are the nominal carriers. But obviously, this trade is happening mostly between or among the three blocks between the US, the EU, and China. And so we'll come back to this question about flag carriers at the end of the talk, because this is one of the more complicating factors in terms of reaching policy solutions. So I'm going to turn it over to my partner here, Hossein, to talk about the next slides.
Sure. Thank you, Andy. To effectively address maritime emissions, I think we must first understand clearly their sources, actually. Talking about CO2 emissions specifically on a global scale, 23% of it is generated by container ships, 19% from bulk carriers, and 13% comes from oil tankers. Currently, maritime vessels primarily rely on fossil fuels like heavy fuel oil and marine diesel oil, both producing significant amounts of pollutants, notably CO2, sulfur and nitrogen oxides, and particulate matter. IMO has already implemented regulatory standards under the 6th Annex of MARPOL on mandating strict sulfur content limits, including no more than 1,000 ppm or 0.1% of sulfur in ECA's emission controlled areas, and global limit of 0.5% or 5,000 ppm of sulfur since January 2020. This is actually globally known and referred to as the IMO 2020 initiative. While these measures have already resulted in reduced sulfur oxides and particulate matter emissions in specific areas, global enforcement and adherence vary significantly. Slide number 6. To start with the most viable alternatives, we will focus first on LNG and LPG. Okay, liquefied natural gas or LNG is currently considered as an effective solution. It reduces CO2 emissions by around 20 to 30% and substantially cuts sulfur and nitrogen oxides emissions. However, LNG presents a significant environmental challenge due to where unburned methane escapes into the atmosphere, reducing its overall climate benefits. On average basis, methane emissions from LNG can reach up to 4% across all engines. Other challenges associated with LNG are high infrastructure costs. As you might know, LNG terminals cost approximately 1 billion each, and there would be a need for new engine technology as well. On the other hand,
yeah, and just keep in mind that, as probably most of you know, methane has much more deleterious effects on GHGs and atmospheric warming than carbon dioxide does. It doesn't last as long as carbon dioxide, but all of this concern around BC's LNG industry is related to the effects it's going to have on global warming.
Yeah, thank you. On the other hand, LPG or liquefied petroleum gas is emerging as a more practical option right now. LPG significantly reduces emissions, achieving approximately an 11% reduction in CO2 emissions and eliminating nearly all sulfur and nitrogen oxides as well as particulate matter. Okay, so this point, most importantly, LPG's compatibility with existing infrastructure, specifically vessels engines, and lower retrofit costs makes it particularly attractive, especially for smaller vessels. Such advantages, we can say, bring us an easier transition to an alternative fuel compared to LNG. Thank you. Okay, now let's explore hydrogen and ammonia. With developing technology of fuel cells, hydrogen is often promoted as the clean energy source of the future. Hydrogen, when consumed, it releases no carbon emissions, positioning it as an ideal clean fuel. However, hydrogen environmental impact depends heavily on its production method. Fossil fuel-derived hydrogen is cheaper but emits CO2, while green hydrogen produced via renewable powered electrolysis is cleaner but more expensive. We can say hydrogen faces substantial implementation challenges. It requires extremely low temperature storage at around -250 or high pressure storage tanks, raising significant practical and safety concerns. On top of that, hydrogen embrittlement can weaken vessel structures, creating durability and maintenance concerns. Also, due to limited existing infrastructure, adoption of hydrogen as an alternative fuel requires major new investments.
So one thing to keep in mind is that There is so much money, as we talked in the last talk, about going into hydrogen. The EU, the US, and even Canada have put in huge investments into hydrogen. And as we discussed the last time, hydrogen, it could make sense if there was an industrial facility near a port where you could use cogeneration to create that hydrogen. But absent that, most of the hydrogen, almost more than 90% of the hydrogen that's being produced right now is being produced from natural gas. So even though it's being posed as a solution for the green transition, it's in fact not being practiced as one.
Yep. Talking about ammonia, ammonia also offers promising clean fuel potential and is easier to handle and store than hydrogen. Nevertheless, ammonia requires significantly larger storage spaces. We can say 1.5 times more volume compared to LNG storage. And it carries risks related to its toxicity, corrosiveness, and potential emissions of nitrogen oxides and ammonia slip. We can say both fuels here, hydrogen and ammonia, present opportunities for deep decarbonization, but will require major advancements in infrastructure, onboard technology, and safety management before widespread adoption can realistically occur.
So remember, with ammonia, the advantage here is hydrogen is a gas, so you need to cool it to really low temperatures, and then you have to have specialized compartments to compress it. So with ammonia, you can turn that hydrogen into a liquid. Now it's a corrosive liquid, so you still need specialized containers, but it's much easier to develop and handle and cheaper than hydrogen in that sense. Now the challenge is that on each end, you've got to convert the hydrogen into ammonia and then ammonia back into hydrogen. So that's where those additional expenses come in, as well as the corrosive aspects of ammonia itself.
Thank you. Next fuel to consider is methanol, actually. Methanol presents an attractive low-carbon fuel alternative for shipping, especially if produced sustainably through projects such as the high-meth ship concept, which achieves reductions of up to 97% in CO2 emissions. Yet, methanol comes with significant technical hurdles, specifically its lower energy density, which is about half that of conventional marine fuels. This ultimately translates into larger storage needs on board and engine modifications due to methanol's different ignition characteristics. Meanwhile, biofuels here, actually including biodiesel, offer an immediately implementable and significant emissions reduction, which is up to 93% less CO2 emissions. However, biofuels' widespread use faces critical barriers, especially sustainability concerns such as competition with food production and the reliability of large volume feedstock supplies, which raises land use concerns and also the long-term availability issue regarding the required feedstock.
So you all have probably heard about renewable natural gas. This is something that Fortis is pushing as a big product. And obviously there is a lot of conversation around sustainable aviation fuels that ties into this. And the idea is you can use organic matter or organic waste to create this methane. As Hossein pointed out, there are problems in terms of engine modifications that would be required for methanol. But then when we're talking about biofuels, it can be blended right into the engine as it exists now. But the challenge there is how much emissions are going to be created in terms of creating that biofuel itself. So like hydrogen, the real question for biofuels is what is the life cycle of emissions in terms of what feedstock you're creating, and how much will it displace food in order to create that biofuel. So in North America, we've been providing these huge subsidies to corn farmers. If you're back east or in Ontario, you'll probably see blended gasoline with ethanol, which is made from corn. And unfortunately, most analysts would say, when you consider all the emissions that are created in creating that corn and creating that fuel, it doesn't make a lot of sense. But there are other fuels, depending on how you produce them, like sugarcane, for example, where there is much more of a net benefit. So there again, it really depends on the production process for the biofuel itself.
Thank you. Now let's talk about batteries and renewables. Battery-powered propulsion systems are promising for maritime emission reductions on short-range operations and ferries, achieving zero emissions on board. However, batteries' practical application for global shipping faces significant limitations due to their limited range, which is around 2,500 kilometers maximum. And also we have an issue with batteries' high weight, long recharge times, and extensive space required on board for ships. Talking about wind-assisted propulsion or WASP, such as rotor sails and kites, they can significantly reduce fuel consumption by approximately 5 to 25%. Yet reliability issues, including the intermittent nature of wind and practical navigational challenges, currently restrict wind propulsion primarily to supplementary roles. Next one is solar power, actually. It can also reduce emissions modestly, typically providing 7 to 8% of a ship's total energy demand due to limited available deck space and intermittent energy production. Overall, we believe that energy sources like batteries, wind-assisted propulsion, and solar are viable as supplemental rather than being the primary source of energy.
Yeah, one area that we'll touch on later too, where it could be more promising to use renewable energy besides the production of hydrogen where that's possible, would be in port facilities. Ports actually rely a lot and they create a lot of emissions. And California, for example, has proactive policies to electrify their ports and to rely on clean energy. So ports themselves could be a really important area of progress for emissions.
Thank you. Given these constraints, integrating hybrid propulsion systems, which is combining conventional fuels with batteries or renewable sources, represents a practical and efficient interim solution, particularly for short-range maritime operations. Okay, and here actually we go beyond fuels and let's talk about engineering aspects and operational measures. Significant emissions reductions can be achieved through advanced engineering and operational efficiency improvements as well. For instance, optimized hull designs can lower fuel consumption by up to 15% by reducing water resistance. Similarly, adopting advanced propellers designs and engine tuning can deliver an additional efficiency improvement of 5 to 10%. Talking about operational strategies, we can say that they play a critical role as well. For example, slow steaming, which involves deliberately sailing ships at lower speeds, can dramatically reduce fuel consumption. Slowing down by 10 to 20% saves fuel proportionally. Additionally, implementing advanced route optimization systems can cut fuel usage by another 2 to 4%, leveraging real-time data and weather information. Finally, port-side solutions like cold ironing, providing ships with shore-side electrical power at ports, effectively eliminate emissions from ships idling at dockside, significantly reducing localized pollution as well.
Yeah, and remember it wasn't that long ago that we were in the pandemic and everyone was talking about disruption of supply chains. So this is a huge issue for maritime shipping. That is optimization of, in our society, everything is just in time. We want to buy stuff and we want it to be available whenever we want it. But that is not actually the optimal situation for reducing emissions. So there's a bit of a tension there between taking slower routes and multiplying those routes so you have multiple ports along the way, and thereby reducing your emissions and the demands that consumers have. So that's another place where policy really could play a big role. Okay, so that takes us to the policy portion, which we've already started to talk about. And as you saw from my last comments, there's a reason why Mr. Trump wants to control the Panama Canal. Just the huge amount of revenues that are generated, as well as the strategic importance in terms of the distance, right? It doesn't seem like it's that much distance, but when you multiply that distance by the amount of freight that's going through that canal on any given basis, on any given day, it's incredible amounts of both emissions and costs that are involved in both the Suez and the Panama Canals. And obviously the biggest challenge there is there supposedly is some Chinese investment in these ports, but more importantly, I think the question is about the US's desire to control its supply chains, right? So here again, we have a tension between lowest economic cost. We know, for example, Chinese electric vehicles are much cheaper than Western vehicles, and that's why both the US and now Canada and the EU have put these large tariffs on Chinese electric vehicles. So what we're seeing is really a retreating from the global trading system as we've known it since 1945. And this is the real essential problem that we're facing with the IMO as well. Like the World Trade Organization, the IMO is a very weak actor in terms of the international system. It has made these great pronouncements around reducing sulfur emissions, around reducing density. But as we talked about at the outset, when you have a lot of your shipping that is under, these nominal flag ships, it's extremely difficult to enforce any of these regulations. So the enforcement, like climate change, essentially is going to come from three actors, which are the EU, the US, and China. And China has made some efforts to reduce its port emissions, but it's really the EU and the US that have made the greatest progress. And that's why when we're talking about any kind of progress in maritime emissions, it's particularly in sulfur, and it's particularly around these ECAs, these emission control areas, such as in California and the EU. And so the EU forces every ship that comes into its ports to comply with its sulfur oxide regulations and eventually with carbon emission regulations. But this is a big challenge for EU competitors, right? Because it adds to ships' costs. It adds to shipping costs, and therefore it's a trade disadvantage. And so that's why it comes back to the IMO again, to resolve these problems over the long run and not rely on California or the EU to be at a competitive disadvantage. But where you've seen progress, it's in these regional areas, and it's mainly in the area of reducing sulfur. And this brings up another global question here, which is about unequal burdens, right? There are unequal burdens in terms of carbon emissions, and particularly about that particularly fall on the small Pacific island nations. It's the island nations and it's the coastal areas like Bangladesh that don't have money for mitigation and adaptation. And you'll recall from the Paris Agreement that the West pledged $100 billion in assistance. And obviously, with the taking off of the sign of USAID, that's a sign that that money is probably never going to come from the West. And so the question then is, what is the way forward in a way that understands the inequitable burden that is going to be placed on countries that are unduly affected by climate change, and also on coastal areas, especially in the global south, that are going to be most affected by climate change. So far, despite the IMO's intentions, we don't really have a system for doing that. The IMO doesn't have a system like the EU of tracking every vessel that is in its waters. It doesn't have the ability to regulate emissions. And therefore, like the UN can talk about peace, they can talk about emissions control, but they don't have the means to enforce it. And so the starting point would be to really create a more robust data system for tracking emissions by shipping. So that's our overview for now. I think, Hossein, if you want to talk about LPG for a moment, we see that as one possible interim solution.
Yeah. Actually, we believe, let me make a reference here. A research in 2023 showed that for small fishing vessels, LPG has the potential to reduce GHG emissions by more than 30% compared to gasoline and diesel. That's why we believe that LPG can be a practical interim fuel solution as an alternative fuel in maritime industry. On top of that, we can say, in addition, we can have hybrid propulsion systems, which is combining engine with batteries or fuel cells for short to medium voyages. And talking about the long-term potential, we think that hydrogen has this potential at first. And after that, we can consider ammonia, methanol, that can have significant potential, but require extensive investment and infrastructure.
Okay, so that's the end of our presentation, and we're happy to take comments or questions. I see that Dr. Wright has a comment. Andy, go ahead.
Hello, folks. I apologise I can't be with you in person today. I'm double shifted and I'm in a noisy environment, so if I do apologise. But I think there's one pathway that you sort of alluded to, but hadn't really sort of dialed into, and that is liquid petroleum gas. Because like the regular vehicle stock, we have a huge standing stock of vessels that they are what they are. Um, but one of the pathways for fuel generation is taking captured atmospheric CO2, combining it with hydrogen through the Fischer-Tropsch process, and you can build any fuel that you like. And so that could all be shore-based and without any modification of existing infrastructure. And I think those kind of pathways have not been explored enough in the world in general as potential ways forward. So that's my 2 cents worth for the day. But great presentation, and thank you very much.
Thanks, Andy. I'll follow up with you to get more details about your suggestion so that we can include it in the paper. Is anyone else? Yeah, Stefan. You have to use this so they can hear you at home.
Thanks for the awesome presentation. Really nice overview of all the different options of decarbonizing this. Actually was considered a difficult to decarbonize sector along with aviation. Those two are always mentioned together. And there are a lot of similarities with the aviation sector also and the whole flag carrier conversation and stuff like that. You mentioned the EU ETS, the cap and trade program in the European Union that is now covering also marine shipping. And it's interesting, I actually first thought it's only covering the reporting of emissions, but I just looked it up. It's actually, even the compliance obligation is now in place. But it will be interesting to see because the first deadline for the shippers to surrender allowances, basically to pay for their emissions, will be this September to cover emissions from last year. So really, the legislation is in effect and stuff, but it will be interesting to see if other countries will actually comply with it and to what extent the EU will be able to enforce it, because the aviation history, the EU also tried to include the aviation sector in its program, and there was huge backlash from China, Russia, the US, also Canada, that in the end brought this system to a halt. They weren't able to put it in place. So it's going to be interesting to see if I don't know if you have thoughts on that.
I think you know better than I do, so I won't say too much in terms of information, but just to reinforce the point that we brought up earlier, which is that the way the EU has gotten around this flag of convenience problem, Art, which is our classic collective action problem, is that when any ship goes into an EU port, it has to register with that maritime enforcement authority. And so it doesn't matter what flag you have on there, you still have to comply by EU regulations before you can unload your cargo. And so that is, to me, a good model to get around that. But you're right, it's a different collective action problem to get the US and China to agree to it. And my concern, as I mentioned earlier, is if they don't, and given all of the fragmentation in the EU that's happening around a variety of issues, this whole thing could start to fall apart. We have the same problem in the US, like everyone is despondent in the US. But if you look at what California is doing in terms of EV mandates, in terms of its port electrification, it's way ahead of other states. And there are other individual states in the US that are continuing to go ahead despite all the lawsuits from the federal administration. Anyone else do you have anything to add? Yeah.
I missed the first part of the presentation, but I'm thinking, have you mentioned something about nuclear reactor, like miniature nuclear propulsion?
So we had a discussion last fall about SMRs, and Alex is our resident expert about that. I think the upshot, at least my conclusion, is that SMRs, they could work in theory, but the technology is still unproven. And you still have the problem of thousands of years of nuclear waste, and what are you going to do with that nuclear waste? So SMRs were a shiny kind of bauble that the Canadian government talked about at the last COP meeting, and there's a very strong nuclear lobby in Ontario. But when you look at the LCOE, the latest levelized cost of energy, unless you're talking about retrofitting existing nuclear plants like 3 Mile Island, Apple is doing that, a new nuclear plant is actually more expensive than wind and battery or solar and battery. So nuclear, to me, doesn't make a whole lot of sense. And obviously, we've been using nuclear power on military submarines for a long time. But to expand that to maritime shipping, to me, I'm a little skeptical. Did you have anything you wanted to add about that?
Yeah, I think you covered most of it, but yeah, it's the price is really, really, really expensive right now, even to a point that it's looking at mostly implementation in really small towns. That's why it would be the small, like modular reactors. But it makes more sense to just build like a nuclear site in most cases. Of course, that's not reasonable for small towns, but the cost is so crazy. Some other research that I've read on, so this doesn't hit everything, but certain types of the reactors actually produce a different isotope in the waste. It's going to make it another challenge to kind of deal with. So I think, in a personal opinion, it's a very interesting idea, and there's a lot of talk about it, but as Dr. Hira said, I don't think there's enough basis kind of behind it yet to start making those promises. Last I checked, I think there's one operational one in the world. So a little bit behind, but it is an interesting idea. I had a quick question. I'm assuming with the flags operating under, the ships operating under different flags, I know that's a way for a country to kind of get away from some liability. What is how does that end up happening though? Like how can the country, what is the policy that allows a country to do that? Like what is the loophole, I guess, or if you could elaborate?
So these subjects, it's kind of like offshore finance. You want to know why companies don't pay taxes? It's because they have an offshore center, right? They have a lockbox in Bermuda or the Cayman Islands, and that becomes their nominal place where they've registered their company, right? And so with shipping, it's the same thing. You can register your ship as this is where we're headquartered. And so it's just a matter of convenience, really, and there's nothing in international law that prevents it. Now, with offshore finance, I happened to do a little research on that. There are some efforts to create a global minimum tax. You remember that was part of Biden's pitch to the world, and it's still stuck in negotiations. It never got past that. So we have all these loopholes in international law. You want to talk about shipping, right? We have these sanctions against Russia. Almost no discernible effect on their ability to ship oil anywhere, right? And so enforcing maritime shipping emissions, very, very tough uphill climb. Anything else, Hussein? You want to add anything?
Just wanted to add this, the Financial Times has an interesting podcast. It's Behind the Money. And on March 4th, they released an episode. The title is Tracking Russia's Shadow Fleet. And it really goes deep into this matter. Based on my experience, because actually I'm a petroleum engineer and I've been involved in bulk carriers and oil tankers. The field of shipping is very complex and complicated. You have an owner for the ship. It has a separate, totally different flag. And so now you have a charterer. That's a totally different entity. And so, it's very complicated to get them, to keep them liable for what they do. Yeah.
Stefan.
I had one more question about the LNG. One of the earlier slides was talking about the viability of LNG as a substitute for heavy fuel oil, for example, and you had some emission reductions there. And I was just wondering if those are based on, do they incorporate the entire life cycle of LNG? Because there's methane slip that's from the combustion. You talked about that, but there's also methane leakage along the supply chain of producing LNG, like upstream natural gas production. So I was just wondering if those percentage reductions of combusting LNG, they do include the life cycle? Okay. Okay, great.
Another very important point, which is there's still a lot of dispute about how much methane is actually leaking from our natural gas. And the BC government, we have another paper on this, hasn't exactly been forthcoming or necessarily very careful in its monitoring. So the estimates of methane emissions keep going up for natural gas. And that's why we think it's a bad deal, not only for the province, but certainly for the planet. Anyone else have any other questions or comments, either online or in the room? Any last thoughts, Hossein? Or?
Andy, Eugene has a question online, and she's saying that is there technology to capture carbon on the ships and then ship carbon dioxide to greenhouses?
No, actually, I don't think so. We don't have such a technology right now available on ships. And honestly, I had an involvement in IMO 2020 initiative, and based on that experience, I can say that ship owners are totally reluctant to make any changes to their vessels or engines. And so I don't think, at least based on the that industry, that's not possible, or actually for now.
So yeah, just closing thoughts, we really need to, as I mentioned in regard to the pandemic, it's forced us to really rethink our supply chains. And it brings up a bigger question, obviously, about circular economies. That is, instead of, we have this, had this tendency over the last century of just purchasing things and then throwing them and they end up in landfill. And now over the last 10 years, we have a recycling program in BC. It's nice, but you know that most of that plastic is not really being recycled. And so we have a huge set of questions that go beyond climate change here in terms of how we produce things and what we produce them from and what kinds of pollution we create afterwards. And we need to start thinking about those kinds of things in addition to how much something actually costs us when we buy it from Walmart. But anyway, thanks so much for your time. And I look forward to seeing you the next time. I think that the next talk is going to be about district energy utilities. And we have Niels Vilstrup coming, and he has years of experience in Denmark as an engineer running DEUs, and also worked for the Lonsdale Energy Corporation in North Vancouver. So thanks again for coming, and thanks for your time.
Thank you.